Good day, everyone, and welcome to another episode of Ratios. Today we're going to be talking about ratios, beginning with 1 piece of bread compared to 5 ducks. That's right, folks. A ratio is simply saying how much of one thing there is compared to another thing. In this case, we're talking about bread to ducks. So we have 1 loaf of bread compared to 5 ducks. Now, that can be written a few different ways. One, you could draw a picture of it like what we did here, or you could simply write 1 to 5, or 1 colon 5, or because the bread was mentioned first, 1 over 5. So, really, that's 4 ways in total. You can draw a picture of it, or you can do any of these other things to represent their ratio. Same thing with squares and dots. We're comparing how much of one thing there is compared to another thing. So in this case, we have 4 blue squares compared to 6 orange dots. We can write that as 4 to 6, or you can write it as 4 colon 6, or you can write it as a fraction 4 over 6. Let's see a few more examples. My personal favorite, kittens to puppies. Well, for every 4 kittens you get, you need 1 puppy. That can be written as 4 to 1, or it could be written as 4 colon 1, or because the kittens were mentioned first, we would put 4 up top and the puppy on the bottom. Now, this also is helpful when you're mixing colors. I don't know if you've noticed, but depending on the ratio of blue paint to red paint that you mix together, you get a deeper purple or a not so deep purple, depending on the mixture. So in this case, we have a mixture of 3 blue to 2 red. So 3 to 2 is one way we can mix it, or write it, or we can go 3 colon 2, or we can do 3 over 2. Now, understanding ratios has really helped us quite a lot. I don't know if you've noticed, but you can actually go to like Home Depot or you can go to Lowe's, and you can take a little chip of your own paint from home, and they will match it exactly because somehow we figured out the exact amount of paint needed to make certain colors. You plug it into the computer, and if the ratio is correct, the color will be too, which is pretty crazy. Now we have 2 of my favorite fruits. What we have here is we have apples and we have oranges. For every 4 apples, you get 4 oranges. So you can write that as 4 over 4, 4 colon 4, or you could do 4 to 4. It's going to be the same. Now, I want you to notice something. What we have here is a 1-to-1 ratio. That means for every apple, we have an orange. We have an equal number of things that we're comparing here, which is pretty darn cool. Now let's scroll on down and do a few more examples. Now for all you chefs out there, we have sugar. Now sugar, this can be really important when we're trying to buy items in bulk. Maybe we're running a restaurant. So let's say I got 1, 2, 3, 4, 5, 6, 7, 8. I have 8 bags of sugar. And for every 8 bags of sugar I get, I need to get 4 salt shakers. So that can be written as 8 to 4. Or it can be written as 8 colon 4. Or it can be written as 8 over 4. So we got pictures, we got colons, we got fraction-looking things, and we got the number, or not the number, but the word TO, too. Now, ratios also become really important when you're creating molecules, right? Because even 1 extra atom can be the difference between water and something completely different. So in this case, we know that water is represented by 2 hydrogens and 1 oxygen. That's where we get H2O from. But if I was trying to write it as a ratio or represent it as a ratio, let's see, I mentioned the hydrogen first. So I could say for every 2 hydrogen, I need 1 oxygen. Or I could write it as 2 colon 1, or I could write it as 2 over 1. Very, very important when it comes to these the quantities of atoms within a molecule and the types of atoms within a molecule. Now, I have a prepared picture. Let's say we want to do a science thing in class, and we need to make sure that for every one student, we have 3 science beakers. Well, what would happen if I had 2 students in the class? Boy, can you imagine? That'd be a huge class. 3 students in the class, or 4 students in the class. How many beakers would I need to provide for each kid? I mean, how many beakers would I need to have in total? Each kid gets 3 beakers. So if I have 2 students, that means I need 6 beakers. If I have 3 students, well, that means I need 3 times as many beakers, so 3 times 3 is 9. If I have 4 students, that means I need 4 times as many beakers, and 4 times 3 is 12, and so on and so forth. I could even use this to figure out how many I would need if I actually had a normal class size of 30. And if I have 30 kids in the class, well, that means I need 3 beakers for each kid, so 30 times 3 is going to be 90. I need 90 of those science beakers. Now, let's move on to tacos, because everybody loves tacos. Let's say I'm throwing a party, and I need to have 6 tacos for every 3 party goers. Well, what if I have 6 people show up? That's twice as many party goers, so I'm actually going to multiply this by 2 to get the 6, and what I do to the bottom, I got to do to the top. That means I would need 12 tacos. But what if let's say that I had 8 times that many people show up. So now I have 3 times 8 gives me 24 party goers, which means I need 8 times as many tacos. 6 times 8 is 48. That means I need 48 tacos. And the final example, did you know that it has been scientifically proven that for every tuba player, there are 6 saxophone players? And that, my friends, is why you should do your research, because I totally made those figures up. But just for our purposes, what would that mean if I had, twice that many? If I had 12 saxophone players, how many tuba players could I expect? Well, I know that 12 is 2 times as many saxophone players, and so if I have 2 times as many saxophone players, that means I'm going to have 2 times as many tuba players, which happens to be 2, and 2 times 2 is 4. And I can continue the ratio on up. Now, another way you could manipulate these ratios is by simply skip counting by 2s on the top. So 2, 4, 6, 8, 10. And then skip count on the bottom. 6, 12, 18, 24, 30. And you can see that these are all going to be equivalent ratios. You also could think of them as equivalent fractions. And those are some other ways that you can view these lovely ratios. So we've talked about ratios and scaling them up, and 3 different ways to write them, including the pictures. I do hope this lesson was helpful to you. If it wasn't, I tried so hard and fell so far. But in the end, I got an A anyways.